is Aditya. I'm a rising junior at the University of Minnesota Twin Cities, and I'm super excited to be here to talk about a cool project I've been working on for the past 6 months called FarmGrid. So just a little bit of exciting news recently. It looks like they already kind of spoiled the news, but FarmGrid has actually been a recent semifinalist in the Minnesota Cup here in Minnesota. So that's super, super exciting. Really, really exciting news, for sure, absolutely. So there's a lot of really cool developments going, and it's just really exciting to have this opportunity. So without further ado, I'll go ahead and jump in with a quick synopsis of what FarmGrid is. So essentially, FarmGrid is an end-to-end IoT system for farms and gardens and lawns that incorporates both a device component that you'd actually deploy on a field, as well as a software integration, which includes a user interface, as well as a database that accumulates data over time from the farm. And really the main motivation for FarmGrid came from this idea that there is a water crisis right now, especially in the agricultural industry. Approximately 800 trillion gallons of water globally is used towards agriculture, approximately 40% of which is actually wasted due to poor agricultural practices and irrigation systems, as well as just evaporation due to water. So FarmGrid attempts to solve this issue by creating a very low-cost device that looks like I'll probably have to be right next to my computer here, which essentially gives farmers the ability to place more devices out there, because industrial grade devices cost an arm and a leg for farmers, which means they're not able to place as many devices out there, and because of that, these devices are going to be pretty spaced apart, and that causes an issue where there's this gap in insight. So FarmGrid attempts to close this loop and gap of insight by getting farmers to place as many devices out there as possible, even if the actual collected data isn't of industrial quality. Because at the end of the day, we're trying to help farmers save money by saving water. Here is a quick illustration of how FarmGrid works. So if you actually scroll down on the website, I created a little graphic using Figma. So essentially how FarmGrid works is within each of these little devices that I built, you have a microcontroller as well as little sensors that are connected via analog to digital channels on the microcontroller. And essentially what happens is a Wi-Fi module opens a TCP connection to a nearby network and actually deploys that data via a PHP REST API to a MySQL database. And then the user interface on the website will actually create a GET request to pull that data out of the MySQL database and display it in a very, very user-friendly way so that farmers can know exactly what's happening on their fields at all time. A very early prototype of FarmGrid was actually meant for indoor applications, and you can kind of see on the screen there, it's that little goofy little thing. Essentially, this was supposed to be made to measure water levels within a saucer or something like that, and that is what that little rating on the top is. That's actually an ultrasonic distance sensor, a hobbyist grade one, and it was supposed to give rough estimations of how water changes over time. And you can also see I experimented with different kinds of soil moisture sensors. You have that little black one, which is a capacitive sensor, but you also have resistive sensors too, as well as your Wi-Fi module at the very top, which publishes the data to the internet on different intervals. And here is the new product, the one that I've been showcasing. I brought two with me here today. And essentially how this works here is you basically have an acrylic cylinder as well as some 3D printed parts. That piece you see at the top is actually a rain cover to house more ambient-based sensors. And what I really mean by ambient here is things that sensors that really need contact with the air in order to give proper readings. So currently, if it's kind of hard to see, but within the actual housing right now, I have a temperature sensor as well as a humidity sensor. And they're actually kind of connected via an outlet within the actual compartment, ensuring that the device is watertight and waterproof. And you also have a little holder right there for your sort of soil moisture sensor, which you can sort of adjust and put back. So that's the little innovation there, and I was really excited about pulling something like that off together. It was really exciting to build, honestly. Here's just another side view of the product. And now kind of moving a little bit more onto the software component. What you're looking at here is actually a dynamic chart that takes the data coming into the database and uses a GET request to actually publish that data every so often. So the little kind of cute icons you see at the top, I designed those via Figma as well. So I was, the whole idea is to kind of create a very lighthearted interface that farmers can use, or even gardeners can use to kind of see how things are changing within their garden and make sure they sort of tailor their agricultural irrigation schedules accordingly. Obviously, nothing too interesting is happening within the chart at the moment. So what you're actually looking at here is temperature, which is the sort of the red line. You also have your light intensity changing throughout the day, as well as soil moisture. The reason I say the data isn't too interesting was because these devices were actually just sitting around in my shelf at home, and that's why you can kind of see that the temperature is basically a constant 67.71 degrees Fahrenheit. So that's really nice. However, what's a little bit more interesting is you can see how the light changes throughout the day, and that little gap there you see where there's really no light intensity, which is the orange line. That is, when I was sleeping at night, and of course there isn't any light in the room, so that's why there's, nothing there. And you can kind of actually see over time that light increasing throughout the day. So even my shelf sometimes gets a little bit of light throughout the day, so that's good to know. So yeah, and something else I just wanted to quickly mention about a user interface like this is that there's actually companies out there currently that charge money for things like this, subscription based, because actually connecting a device and getting it to publish data isn't necessarily an easy task. You need to run servers, you need to run databases, and especially when you're trying to create a startup and trying to scale a product, you run into a lot of issues with kind of keeping up with scale, and a lot of that can be a big issue. So trying to create a user interface like this has been a really big leap for FarmGrid, and kind of having that device and software component really ties together this end-to-end IoT integration I've been speaking about. There's just a little bit of a boring chart, but there is something very, very interesting to note here. The battery level within the last 3 days, and you can kind of look from the timestamp, hasn't changed very much at all because the microcontroller within the devices are designed to be low power in application, meaning that when the device isn't publishing data to the database, it is basically on a sleep mode, which means that the actual CPU and the processor within the microcontroller aren't on, and there's basically a watchdog timer that tells it, okay, wake up now, sample the ADC, analog to digital channels, collect data, and then sleep again. And you can kind of already see the benefit of that right there. The battery level hardly changed at all in 3 days. So that is also a really, really exciting thing about this project. And then just another little thing here is that what's really nice with these devices is they're designed to be very minimalistic for a reason. You can connect these with irrigation systems and actually send messages back to the device so that it can control stuff like solenoid valves, which control gardens, and you can really manage your water system like that. So there's a lot of ways this can go, and I'm planning on exploring everything, which leads us to our future offering for FarmGrid. There's a whole lot of really, really interesting applications for Internet of Things, and one of them, especially, which is super, super big in the industry right now, is energy autonomous devices. And essentially what I mean by that is devices that you can just chuck outside, throw outside, and it will just be able to charge its battery and run for years and years at a time. No need to, hunt down that device on your 100-acre land. Just leave it out there, let it collect data, and just view it remotely from anywhere in the world. And that is what gets me excited about Internet of Things. The possibilities are literally endless. And think also about how big data has become such a driving force, especially within our industries today. Think about what you can do with tons and tons of data like this coming in from all points of your farm throughout the day. You can start applying things like machine learning techniques, your regressions, and start making predictions based on how quickly water seeps through the soil. Send a message or something to your phone when it seems like your garden is starting to get dry. Make maybe basic forecasts of what the weather will look like, especially if you're in very remote areas. You might not have very accurate ways of measuring the forecast. And even cooler, you can start building things like mesh networks where each device becomes basically a Lego in a large mesh. And especially if you have a very, very large acreage of land, you can have these devices basically communicating and transmitting data to each other, propagating data between them until it reaches somewhere where there is network connection. You can actually publish all that data at the same time. So that's essentially that. And then, of course, a little technical difficulties there. Of course, though, the whole idea of kind of maintaining low power is something I'll continue to explore, how to make these devices last longer and longer, because by doing so, really the whole idea of making things like this is for convenience for farmers, for industrial, for industry-based purposes and greenhouses. Have this thing running out there, have it apply machine learning and data analysis techniques on the data coming in, and do some very, very cool stuff with that. So with that said, that is just a little bit about FarmGrid. If you're interested in learning more, you can find my info on the About page. You can actually visit the website at farmgrid.ml. I decided to use the ML extension mainly because I wanted to make this as low cost as possible for just prototype purposes. So I didn't buy any domain names, I didn't buy any this, that, I didn't buy any databases. Everything was low cost, everything was for free. The microcontrollers were like $2. Everything is just meant to be low cost because money is hard to earn, and it's very, very important that we're trying to save money, especially for something as valuable as water. So feel free to reach out to me. If you hover over my name, it will lead you to my LinkedIn page. If you're ever interested in updates or hearing more about this product, feel free to reach out. I'd be happy to stay connected. But with that said, that's FarmGrid, and hopefully I excited you a little bit about Internet of Things. Thank you.